Let us start with the topic of nuclear reactions. In previous topic we already studied about formation of nucleus, which is also a nuclear reaction in which protons, neutrons fuse together to form a nucleus, and some energy is released from the rest mass energy of the reactant of the reaction. Similar to that, let's have a look on this nuclear reaction where there are two nuclei A and B are moving toward each other with some kinetic energies, and when they collide, due to their high kinetic energy, their distance of closest approach will be very small, which is of the order of nuclear separation, and so nuclear forces come in picture, and the nucleus, an intermediate combined nucleus is formed, which have the excess energy due to the initial kinetic energy of nuclei. And this intermediate nucleus which is produced, if it is not stable due to excess amount of energy, it further disintegrates into two or more nucleides. Like here you can see two nuclei C and D are produced, which are traveling in opposite direction to conserve momentum if initial momentum of system was 0. So here you can write the final nuclei which are produced as the product of the reaction are C and D. So here if we write down this nuclear reaction of this process, here we can write here nuclei A and B combine each other and produce an intermediate nuclei. Here this star symbol denotes the excess energy in this nucleus, which is considered to be the excited state of nucleus, which is not stable, and it further disintegrates into two nuclei C and D and releases the excess energy in form of kinetic energy of the particles C and D. And in this situation, obviously here we can see as the final end product which are thus produced are not A and B. That means C and D nuclei are more stable compared to A and B. That means these have relatively lesser energy. So here also this energy must be released due to the mass defect of this reaction. So here if we calculate the mass defect of this nuclear reaction, then this can be written as delta M is equals to mass of A plus mass of B minus mass of C plus mass of D, as if C and D are more stable, then certainly their rest masses will be less than the rest masses of A and B. And here if we calculate the amount of released energy in this situation, then this released energy delta E can be written as delta MC square. And if this mass defect is given an atomic mass unit, then it can be written as delta M multiplied by 931.5 million electron volt, if this mass defect is given in atomic mass unit. Now here this released energy in this reaction is also called as Q value of the nuclear reaction. Q value, this term is derived from the quality of nuclear reaction. If in a nuclear reaction more energy is produced, then we say its Q value is more. Let's continue on the next sheet about Q value. Let's continue our discussion on Q value of a nuclear reaction. We have discussed that it is the amount of energy which is released in a nuclear reaction. About Q value, alternatively, we can also written that it is defined as the difference in rest mass energies of all particles and nuclei before a reaction and those of products formed after reaction. Obviously, if the products formed after nuclear reaction are more stable, then we can directly state the final rest mass energies of the products will be less compared to the initial rest mass energies. So directly by taking the difference in rest mass energies of reactants to the products of a nuclear reaction, we can directly get the Q value of the nuclear reaction. Now from the next section, we'll study about different types of nuclear reactions.